Lesson 17, lower limits of option prices. Here, what you will learn now, why the price of an option must always be not lower than its intrinsic value. Both put and call prices also have lower limits, which can be derived introducing some mathematical concepts. Let me say, it is much easier than it seems, so stay focused and listen carefully. Let's consider two portfolios such as the following. Portfolio A, a European call plus a money amount equal to the present value of the strike price, KX minus RT. Portfolio B, the underlying stock, valued as 0 in the beginning, the current value of the underlying, the current value of the stock. Given portfolio A, if we invest the money KX minus RT at the risk-free interest rate, in time t we get K, it becomes K. If in time t the call is in the money, that is ST, the underlying in time t is greater than K, the call is worth its intrinsic value, so ST minus K. So the portfolio A in time t, if the call is in the money, is worth ST minus K plus K, so ST. Portfolio B is always valued ST, S0 in the beginning, ST in the end. If, on the other hand, the call expires out of the money or at the money, it is valued 0, and the global value of portfolio A is reduced to K. As a consequence, at the expiry of the option, portfolio A is worth the maximum between ST and K. If the underlying at maturity is higher than the strike, the portfolio is valued underlying. Otherwise, it is valued the strike of the call. Let's go through all of this again in another way. Here we have the portfolio, the initial value of the portfolio, the scenario at expiry, the moneyness of the option in that scenario, the final value of the portfolio, and the comparison between the two. Portfolio B is S0, just the stock. No matter the scenario at maturity, there is no moneyness here, we don't have options here, the final value is ST. That's it. Portfolio A, it depends on what happens at maturity, which of the two scenarios we pick. If the scenario at maturity is that the underlying is higher than the strike, the call is in the money, the initial value of the portfolio is the call plus the current value of the strike. At maturity, the call is valued underlying minus strike, ST minus K. K times exponential power 2 minus RT becomes K. So S minus K plus K, it's S. And A, it's equal to B. They have the same value. What if, in the other scenario at maturity, the underlying is lower or at most equal to the strike? The portfolio in the beginning is still the same. The moneyness of the option is at the money or out of the money. The value of the portfolio in the end is 0 for the call plus K for the money invested, so it's K. And in this case, ST is lower than K, so K is bigger than the underlying. So A is bigger than B. Let's go through this again. If ST is lower than K, since A in this situation is valued K and B is valued ST, ST lower than K, B lower than A. So the conclusion is that no matter the scenario at maturity, A is always equal or even higher than B. In summary, portfolio A is always worth at least as portfolio B, sometimes more. This relationship must be valid in time 0 as well. So C plus K times exponential power 2 minus RT has to be higher or equal than S0. which shows the lower limit of the price of European coal. We take this and we put it on the other side of this equality, and we have C higher or at most equal to S0 minus K exponential power 2 minus RT. And what is underlying minus strike? It's the current value of the intrinsic value. So the price of a coal cannot get below its intrinsic value. More or less, this is what we have seen so far. What about the lower limits to put prices? With the similar reasoning, it is possible to derive the lower limit to a puts price. Let's consider in fact the two following portfolios. Once again, it is much easier than it seems. Portfolio C, a European put plus stock valued as 0 in time 0. Portfolio D, a money amount equal to the present value of the strike, K exponential power 2 minus RT. If in time T, the spot price is below the strike, the put is in the money. Let's go straight to the table. Portfolio D is the present value of the strike. No matter the scenario at maturity, the final value is K. This is the money amount that invested on the time equal to the maturity of the option at the interest rate R on a yearly basis becomes K at the maturity of the option. The portfolio C is the put plus the stock. If the stock at maturity is below the strike, then the put is in the money and it is valued strike minus underlying. So the put is strike minus S. S0 becomes S. So K minus S plus S makes K, and C it's equal to D. The other scenario is that the underlying at maturity is greater or at most equal to the strike. In this situation, the moneyness is at the money or out of the money. The put is valued 0. What remains is the underlying. And since the underlying is greater than K or at most equal to K, then C is greater or at most equal to D. So no matter what happens at maturity, portfolio C is always equal or perhaps greater than D. And this relationship has to be valid in the beginning too. So P plus S0 has to be greater or at most equal to K times exponential power 2 minus RT. And if we take S0 and we bring it to the other side, we can say that P is always higher or at most equal to K exponential minus RT minus S0. And what is this? It's the current value of the intrinsic value of the put. Once again, prices of options cannot fall below the present value of all their intrinsic values. And for now, that's all also about lower limits to options prices.